JSON Web Tokens, or JWTs, are a standard for securely transmitting information between parties as a JSON object. In essence, it's a way to say, hey, I know who this user is, and here's some information about them that you can trust. It is particularly useful in scenarios like user authentication for web applications and APIs. A JWT consists of three parts: a header, a payload, and a signature, each playing a vital role in ensuring the token's integrity and validity. Let's explore how these components work together to provide secure user authentication. Let's take a closer look at the structure of a JWT. A JWT is represented as a string consisting of three parts, separated by dots. The first part is the header, which typically specifies the algorithm used for signing the token, such as MAC SHA-256, and the type of the token, which is JWT. The second part is the payload, which contains the claims or the information being transmitted, such as the user ID, name, and issue time. The third part is the signature, which is used to verify that the token hasn't been tampered with and that it was issued by a trusted party. All the three parts are base64 URL encoded. Let's dive deeper into the header component of a JWT. The header typically consists of two parts: the algorithm, commonly abbreviated as ALG, which specifies the cryptographic algorithm used to generate the signature, such as MAC SHA-256, and the type, abbreviated as TYP, which indicates that it is a JWT. This header is then base64 URL encoded to form the first part of the JWT. As we can see, the encoded header is UIJHBJOJIUZI1 and I is in R5CCI6XVCJ9, and when it is decoded it is ALG is HS256 and TYP is JWT. Now let's explore the payload component of a JWT. The payload contains the claims, which are statements about the user or entity being authenticated. These claims can include registered claims like the subject, issuer, expiration time, as well as custom claims specific to the application. Common claims include the subject, or SUB, which identifies the principal that the token is about, the name, which represents the user's name, and the issued at time, or IAT, which indicates when the token was issued. Like the header, the payload is base64 URL encoded. For example, here is the encoded text: EYJZDWO9MJM0 and I30DKWI WebMFTZSI6654GRG9 Aliwia WF0IJOXNT2MJM5MDEFQ. And the decoded version is sub is 12345678990. Name is John Doe and A 1516239022. Let's now discuss the signature component of a JWT. The signature is generated by taking the base64 URL encoded header, the base64 URL encoded payload, a secret key, and the algorithm specified in the header, and then using that algorithm to sign the combined data. This signature is crucial for verifying the integrity of the token and ensuring that it hasn't been tampered with. The MAC SHA-256 function takes encoded header and payload and secret as an input and generates the signature. Let's walk through the typical workflow of using JWTs for authentication. First, the client sends their credentials, such as a username and password, to the authentication server. Second, upon successful authentication, the server generates a signed JWT token containing claims about the user. Finally, the client includes the JWT in subsequent requests to access protected resources, and the server verifies the token's signature to ensure its validity. This process allows for stateless authentication, where the server doesn't need to maintain session information. Let's explore the key benefits and common use cases of JWTs. Some key benefits include being stateless, eliminating the need for server-side session storage, being scalable, making them ideal for distributed systems, working across different domains, enabling cross-domain authentication, and being self-contained, with all necessary information embedded in the token. Common use cases include API authentication, providing secure REST API access, single sign-on, enabling cross-application authentication, Mobile apps allowing lightweight token storage, and microservices, facilitating service-to-service communication. Now, let's address some important security considerations when working with JWTs. Some best practices include using strong secrets, employing cryptographically secure keys, using HTTPS only, always transmitting tokens over secure connections, setting short expiration times, configuring appropriate token lifetimes, and validating claims, always verifying the token's contents. Additionally, some security warnings include avoiding storing sensitive data in the payload, securing client-side token storage, verifying the algorithm to prevent algorithm confusion attacks, and considering a token blacklisting strategy for revocation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.